Welcome to part 2 of why use the cloud. We saw in part 1 that there are various use cases for why we would want to use the cloud, what people have done in the cloud. And we considered various factors about those solutions: the cost, scalability, access, configurability, variety, upgradability, security, simplicity, dependence, and maintainability that we have to explore every time we consider putting our solution in the cloud. As we saw in part 1, one use of cloud is the ability to scale up when you need to. And one aspect of this is in DevOps, particularly when you're doing testing and development together, when you're doing an iterative cycle. You can test your code on variously configured systems. That could be different operating systems, different versions of an operating system, working with different software, by spinning up VMs, testing it, running through all your tests, logging all of this. And then when your testing is done, you can release all of those. So you're paying for the resources you're using during testing, but you're not committed to them at other times in the process. So you're not committed to them during production. You're not committed to them when you're doing more planning and development. So it is a scalable solution to your whole DevOps lifecycle. So you can provision the size and capability of your resources with a wide range of different computing resources are there that are there in the cloud. If you try to do this in your own data center or on your own servers, it would be very costly and inefficient, because you would have to have the people that set up these instances, that make sure that you have the latest operating systems, you'd have to set up different versions. All of this would either take time or increased computing resources. And so doing this in the cloud is very cost efficient. You have all the variety of the different systems that the cloud allows you to have, and it's very accessible to doing this. This also, in another part of the life cycle, can be used, cloud can be used for proof of concept and minimal viable product if you look at the lean methodology. So when you want to get a proof of concept, a prototype, an MVP up, you can do this at a fraction of the cost of having all the final infrastructure that you would need. So if you are thinking of making a system that's going to need various infrastructure, you can test this out before you commit to actually buying all that infrastructure. So even if you don't want to put the final production on the cloud can still help you by letting you test out all different versions of your prototype or proof of concept. And so you can use the cloud to quickly provision up resources for a minimal viable product. If you're using lean, it allows you to get a version up with just enough features so that it can show people, and you can show them easily because it's in the cloud, so it's accessible. And so you have cloud being useful for everything from the conception of a product right to the provisioning of the product. And this also leads us to the advantage of many large public cloud platforms, in that they have some unique hardware that you can use. They usually have very up-to-date hardware. They can have hardware that you yourself might not want to invest in for the long term, but you might want to try it out to see if sometime down the road you might want to use it. So there's GPUs, now quantum, very large memories, very powerful chips that represent a substantial investment. You can also test out, if you're using multiple virtual CPUs for your system, just how many you need, what the performance differences are. And so you can get these very unique, up-to-date hardware configurations, and you can test them out before you either commit to them in the cloud or commit to them in an on-premise system. They're also set up now for big data analysis and manipulation. You have all of the storage facilities that the cloud has, so it's quite easy to store large data sets and maintain them there. You can also, once you've used them, if you still want to have them around but aren't using them all the time, you can put them into archival storage so you don't have to spend as much money. You have backups for that, and you can actually use some of the services on the public cloud providers that have been specially tuned to do big data analysis. And so when you're starting to invest in this, you can look at the services that cloud provides and try them out before you totally invest maybe in your own individualized resources for that. Or you might determine that you can just stay with the resources and services provided by a public cloud provider. Because of the global reach of cloud in all sorts of ways, the fact that there's data centers all around the world, the fact that it's provided via the internet, means that you have global business operations being facilitated. So it makes it easy for you to actually access clients or users all over the globe. But one of the problems that you have with this is that there are different laws in different jurisdictions. And this can obviously be an issue when you're trying to roll out a global service. And then you might have to worry about where you store data or what you do with it, depending on where the servers are. And so one of the things that the public cloud providers have provided are facilities to help people comply with government or regulatory demands. So the governance over the cloud, basically governance over data or data centers that are in various jurisdictions, you have differences in those governance regimes. And the public cloud providers provide tools to help you navigate these regulations. They can be very challenging, and you may be running into them in multiple parts of the world. So it might not be just one regime that you have to negotiate. It might be many of them. And so the global cloud management services help you. They've already set up all the lawyers. They have people that have gone through all of the regulations, and they can guide you through how you manage in an international setting. So with AWS, if you have data residency requirements, in other words, if you're worried about where the data is, so maybe you want to provision it very close to where your users are, what you want to do is you want to make sure that you can comply with whatever region you're dealing with. And so if your data is physically located somewhere, you're going to have to figure out, can you meet these compliance and data residency requirements? And so AWS has compiled a set of services and tools that you can use that will allow you to comply with global data protection and regulations. And they've built this all up so that you can build a GDPR compliant infrastructure on top of AWS. And so GDPR is a regulation in EU law, so the European Union, for data protection and privacy when you're dealing with EU and the European Economic Area. And it also addresses the transfer of data between various areas in the EU and the European Economic Area. These are much more extensive than you would hit in most other jurisdictions, particularly the United States. And so there does have to be due diligence done if your software and data storage is going to be dealing with the EU. Azure also has tools to help you with this. They have the Azure Security and Compliance GDPR Blueprint, and helps you build and launch cloud applications that meet the GDPR requirements. And they also have a compliance manager, which is a free workflow-based risk assessment tool, and they will step you through all of the different things you have to do to track, assign, and verify that your organization is complying with the GDPR regulatory requirements. And these are very helpful services to have because of the fact that the EU is a big area for selling software or gathering data or storing data, and they have the most extensive rules governing privacy anywhere. And so if you can comply with them, you can comply with almost anything. And so they help you do that. Now, I've mentioned a few times in the first learning modules about IoT, or Internet of Things. And with IoT, we have this environment now, this ecosystem where we have all of these sensors that are out in the world. They can be very complex, large sensors to ones that cost pennies and that are just like thrown out into like agricultural fields or spread around a city or attached to an animal or whatever. There's all different forms, but their scale is immense. And so with the Internet of Things, you have the data ingestion stage where the devices are sending their data in through some sort of transmission. So you have to have a transmission medium. Then it goes to, generally, it's going to go to the cloud. And then you're going to have to do data processing there and then do something with it. Maybe it's visualization, analysis, prediction. And maybe in some of them, it's going to be control. And so you have a very short loop because you have the ingestion, transmission, processing, and right back to the transmission and ingestion stage for the device. And so IoT management now on the cloud, it is becoming a large service that the public cloud providers give you. So what you want to do with IoT management is you want to be able to manage and utilize smart devices. And there's lots of them. So cloud environments have to be capable of handling that data, sometimes in near real time. And what they've done is they've built specific packages and infrastructure to do this. And so with in the AWS case, they have AWS IoT. And so they have software that allows you to securely connect to devices, gather their data, and take various actions, even when sometimes you don't have connectivity. So they may be doing things on they provide you with the software where it will go to the cloud, but if it doesn't, it'll do something else. You also have connectivity and control services that allow you to get the data in and out of this huge swarm of devices that you're dealing with. And then within the cloud, there's analytical services that help you process this data, because the data, what you get is huge amounts of data. It may be very simple data, but there's huge amounts of it and it's coming in all the time. And so you have to have services that help you do this. So you have the connectivity and control, the analytics, and you have the software to allow you to get this from devices. So there's an AWS IoT Core. This is a platform that allows you to connect to devices and provision out secure data storage. It also allows you to process and act upon this device data, and it allows applications to interact with the devices. And the one specialty device that they allow you to have interaction with, they have special tools for this, is their Alexa system, which is like the digital assistant devices that you have in your home that you can ask to do various things for you. Not to be outdone, Microsoft also with Azure has its own Internet of Things suite. They have various cloud services that allow you to connect, monitor, and control your IoT assets, even when there could be billions of them. And you have the IoT devices and one or more backend services running in the cloud that creates this ecosystem of IoT. They have something called the IoT Hub, And it's a managed service, it's hosted in the cloud, and it acts as a central message hub. And this allows bidirectional communication between an application and the devices that it manages. And so you can use this IoT hub to build solutions for your devices, and it will establish a reliable and secure communications between all of this, of all of your devices in your IoT ecosystem, and with this cloud-based back end. Now, when you're doing all of this, whether you're doing IoT or you're doing web or you're doing whatever type of application, app testing and development is going to be something that people are going to go to the cloud for. So you can get specific developer tools for building and testing out mobile applications. If you go, one of the, I'd say, probably best structured of these services is Microsoft's Azure App Service. One of the things that is good about this is that it really does link you in totally into the Microsoft universe. And so you can get all of this organized through all of the different Microsoft tools, development tools that are out there, and it's all integrated. So if you, and AWS has its own system, but the difference between these two platforms, cloud platforms, is that obviously AWS does not have any skin in the game when it comes to development tools or environments on your laptop or your desktop. They're totally in the cloud. They will provide APIs, that sort of thing, SDKs, various services, but they're not providing you the development environment. Microsoft already has that. And so they've integrated it into their cloud service. So it makes it actually very easy to, if you are already working in the Microsoft development universe, to connect to the cloud and go seamlessly back and forth. So with the Azure App Service, you've got the ability to create various systems that will interact with mobile devices, from Windows, from Apple and the Google Android system. They provide REST APIs. They have all sorts of user authentication abilities, including their own, which is Active Directory. They allow you to sync to their data storage, and you can do all sorts of notifications. So they have a whole ecosystem set up, and it's all integrated into the Microsoft universe. With AWS, they amplifies a development platform for doing this. It's there's libraries, there's a command line interface. It's open source. It has it has a pluggable interface that you can customize and create your own plugins. But it's not really the same as the Microsoft universe, but it does allow you to do some of the same things that we saw with the Azure App Builder. And there's a new thing that's just come out that looks very interesting, and it's called Honeycode. This is from Amazon. The beta was released in June 2020. It's so new, they don't even have a price for the service yet. They're just allowing you to run with it for free. What they want here is for you to be able to write code for mobile and web applications. They want you to be able to create and start a service without really writing too much code. It basically uses a spreadsheet model, and you take these templates that look like spreadsheets, you fill some things in, and they allow you to generate some common applications. So surveys, to-do lists, trackers, managing inventory, event management, those sorts of things. And right now they only have a certain number of those because it's all just starting out. But the nice thing about this is actually after you develop it, test it out, the final app can be distributed as a link so that you can use it on the web. Or if you want mobile usage of it, the user just has to install the Honeycode player. So, this is for iOS or Android on their device, and then your app plays within that. So in other words, you get access to both universes, the iOS one and the Android one, in the mobile world without having to write native iOS or Android applications. So this is very nice if you want to hit a customer base that could be using either an iPhone or an Android device. And this is an interesting development that Amazon has for quickly rolling out generic mobile applications. So it's something to keep an eye on. And I've got a list of sources here where people are talking about what they've done in the cloud, just to give you an idea for how people have conceptualized and thought about the advantages that cloud gives them. So this concludes our set of modules where we're looking at what cloud is, what are the pieces of it, what is it supposed to be doing for you, what services are out there, how's it organized. And so what we're going to do now is that we're going to start looking specifically at these basic services, and we're going to concentrate first on the Amazon world, the AWS world, and then we'll also look at Azure and Google Cloud Platform.